So welcome to this talk. I'm going to quickly introduce myself. My name is Ju. I was born in China. I grew up in Italy, and I've been living in the UK for some time. I've been working for this company called Nerves Inc., where we teach English grammar and writing to kids. So I just wanted to give a very quick rundown of the structure of this talk. It's not serious at all. So the first part is doom and gloom, and we're going to talk a bit about the state of things in the smart devices ecosystem. And the second part of the talk is what we can do about it as engineers. And when I think the current state of the things and what we can do about it, I think it helps a lot to be stoic about things. So if we just use Epictetus's words, we should try to make the best of what it is in our power and take the rest as it naturally happens. And I think that helps a lot to, keep you calm and move on. Before we start, I want to underline that what this talk is not going to be about, even though it's called Taking Back Control, it has nothing to do with other types of taking back control. Although I think we are facing an adversary which is as loathsome and abominable as this one. It just looks slightly different, right? It looks something like this. And I have to preface, I'm literally waiting for an Amazon delivery. So it's like, not that I don't use Amazon. I just have big problems with their smart devices lineup. So this is an Echo. And there's many reasons why I don't like buying these devices and seeing people buying these devices. Apparently, there's hundreds of millions of these devices in people's homes around the world. Well, and the reasons why I don't like these devices, I'm not going, there's not my reasons, so I'm just going to read through them, yeah? So Amazon workers are listening to what you tell Alexa. Amazon confirms it retains your Alexa voice recordings indefinitely. Judge orders Amazon to turn over Echo recordings. And there's also then basically former Amazon employees talking about how they handle data, right? So there's this article in The Guardian, and there's a former Amazon engineer, and he says, I felt a bit foolish. Having worked at Amazon and having seen how they used people's data, I knew I couldn't trust them. Yeah, so I think this is my general feeling about the whole smart devices ecosystem. And this is nowhere as bad as it could be in the near or not so remote future. There's another Amazon company which is called Ring, and they are a smart doorbell sort of company. Yeah, this is one of the products, and the tagline says, "Replace your existing doorbell with smart security." Right? I personally have a proposal to replace this tagline with another one which I think is more truthful, which is one ring to bring them all, and in the darkness bind them. I'm not sure how the PR department of Ring will take this, but I think this is way more truthful than the current one. And I guess, I could be seen as overly dramatic when I'm comparing a smart doorbell company to the Dark Lord of, Barad-dûr. But I don't think I am. There's this amazing ad that they released recently. You can watch it later. But basically, let me just bring, but basically you can see this is their sort of, push for a new product. There's this thief, and you have this beautiful drone, and it says, oh yes, and you can literally walk around your house and record everything and see everything when you're not at home, right? And this seems pretty nifty, right? Until you start thinking about the implications. So yeah, you can see in that ad, they say, oh yes. But then you read things like, Ring has partnered with 400 police forces, extending surveillance concerns. And then you start thinking that all these cameras that we are adding outside and inside our homes, they don't really have our lives and our privacy as their primary concern. Their primary concern is to make money for Ring or Amazon. In one way or another, it will be used for that purpose. So the funny part about this article is it was published on the Washington Post, and therefore there was this paragraph. Ring is owned by Amazon, which bought the firm last year for more than $800 million. Amazon founder Jeff Bezos owns the Washington Post. Well, my reaction to that is a big, oh no. So what is the point that I'm trying to make? The point is that if you are a user of a smart device, you have literally no control over what it does. It might work now, it might stop working in the future, it might be sending your data, it might not. You just don't know. And no matter how well-intentioned you think the maker of that device is, so maybe you've learned about this new startup and they're very privacy-focused, security-minded people, and you really trust the product. But it will happen if they are successful that they get acquired by another company. And then at that point, well, if you are lucky, all your data will be sold and some other huge data mining framework will be run on it. And if you're unlucky, your device will be bricked. So it just will be a nice piece of metal and circuits, but it just will stop working. And I just want to bring two simple examples of both points. First point, Snips, privacy by default voice technology acquired by Sonos. So this was a French startup that they were doing this sort of voice activated speaker, and they were very privacy focused. And last year they got acquired by Sonos, the whole company. So, it'll be basically up to Sonos if they want to keep, being privacy minded or investor minded. An example of the second case, Revolve. And this was a smart thermostat company, and they got acquired by Nest, which in turn got acquired by Google. And after the Google acquisition, Nest basically shut down all the Revolve thermostats that were in people's homes. So, and though this was like high-end devices, like $300, $400, and you buy this device, and then after a year, it just stops working. Like the server has been shut down and just doesn't work any longer. So that made me think, well, why do we buy these things in the first place? Why do we buy the Echo or the Nest thermostat? I think the first reason, because they look cool. They're like these gadgets, they're fun and they're modern and they're sleek. And the second thing is that they fix some minor annoyance in your life, right? You don't want to go home and have to turn on the heating. You want to do it from the office, right? Or let's say you're making some bread and you want to convert amount of grams in a teaspoon, and you use Alexa for that. And they can be cool because they're internet connected. So the reason why we spend $400 for a smart thermostat is because it can communicate with the outside world. But ultimately, they're not essential to our lives, right? So if you really think about it, ultimately, we're trading our privacy and our lives to know what's the weather like in Glasgow. And spoiler alert, it's raining. So I think that's like really telling of what sort of society we're living in. So if we don't want to give up to these little nice additions to our life, what is the alternative? In my view, the only alternative is to do it yourself. Because the only way to trust a smart device is to know exactly what it does. Well, with some limitations, right? Like I pretty much trust the Linux kernel or OpenSSL as a library. But other than that, I don't trust at all what a new startup will do with the software stack on the device that they put in my house, right? So the only way to completely know that, to own the whole stack, can happen if you build the whole device yourself. And no, there is no other way. Like if you buy something off the shelf, you just don't know. And I know that it takes time and effort to become, acquainted with hardware, to, learn how to connect chips and how to use them and everything. But I think in the software industry, we're pretty used to learning, right? We can learn to use Kubernetes. I'm sure we can connect some chips and pins together. So I think that as engineers, we are in this uniquely privileged position to be able to do something about it, right? If you take someone that doesn't have technical skills, it will be very hard for them to tell when something is done right, when something has the privacy and has your privacy, secure, and thinks about security. And if you're not an engineer, you just can't do that. And I think like if you have that sort of power, you shouldn't let it go to waste. And even when we're doing that, I always think of this quote from Arthur C. Clarke, which is that any sufficiently advanced technology is indistinguishable from magic. So we use, all these cool devices every day, and just going down one layer and trying to understand a bit better how do they work, I think it's incredibly satisfying. I was watching the talk by Andre about how to build a keyboard, like a keyboard controller in Elixir. And, you use the keyboard all day, but you never really think about how does it work? How does it repeat keys and all sorts of things like that. I think it's really cool to learn more about that. So yeah, I think it's time to just, do stuff and stop whinging. In this talk, I want to talk about, of course, Elixir and of course, Nerves. But I don't really want to give the usual spiel about, how easy it is to install or, how to create your first Nerves app. I think if you go through on our website, it's pretty clear and easy to do it. What I want to do instead is just to take a couple of examples, if I have time, and think about what is the difference of making something like that yourself compared to buying an off-the-shelf product, right? So the example that I want to give is very close to my heart, and it's related to this little device. So this is a mocha pot, and it's used to make coffee. It's very popular in Italy. I think every household has at least 2, maybe 3 of these mocha pots. And they work like that. There's like this lower chamber, and you fill that with water. And then inside, there's a little metal basket where you put the coffee. Okay, I think I have a better image. Yeah, there we go. And you have the coffee here. And then you put the whole thing on the stove. Once the water starts boiling, the steam goes up this little pipe, goes through the coffee, and starts dripping upwards slowly, up until to the point when there's almost no more water on the lower tank, and therefore, your upper tank is completely full with coffee. So I use this every day, and especially, working remotely, I just go to the other room and make the coffee. So I wanted to talk to you about my first world problem. I say first world problem because, I have food, I don't have to worry about rent. So really all my problems are first world problems. So usually I go to the kitchen and I fill up the mocha. So I put the water and I put the coffee. Then I put it on the stove at a low setting. And this is important because the steam has to go up slowly to extract the full flavor from the coffee beans. At that point, I don't want to really wait 10 or 15 minutes in the kitchen waiting for the coffee to be ready. So I'll go back to the office to work on some stuff. But I have to keep the doors open so I can hear the rumbling of the mocha pot. In the meanwhile, I get distracted because, there's some problems and I just get focused on something else. and I run to the kitchen when it's too late, and I get burnt coffee. So this makes me very sad. So instead, I thought, what if I built a machine which can tell me when the coffee is ready and just like lets me know? So this brings me to the demo. Let me see. Okay, how much time do I have? Enough time. That's good. I have to hide some stuff. Let me know if something is completely unseeable. So I'm in this folder. I've created this Nerves app, which is called OK. And it's a normal Elixir, Elixir and Nerves app. So I'm just going to quickly show you the application EX. You see, it uses application and uses these three processes. One is a sensor that is able to measure temperature and humidity. One is a physical switch, which I will use to activate the machine. And then we have a server process, which is, the brains of the whole thing. I'm super proud of this. I made this amazing looking ASCII diagram. Look at this, it's glorious. But basically this is how the machine is supposed to work. It goes into this idle state. When you press the button, it starts checking humidity. When it says that the humidity level has been reached, it sends me a text. When the text is sent, or we fail to do it, it goes back into the idle state. So it's like this very neat little state machine, right? So I'll keep this on the right-hand side, and on the left-hand side, I'll put, ta-da, the machine. So this thing is on my desk. It's connected to a Raspberry Pi 3. Let me just quickly show you, well, first of all, that I'm not lying. It's like, that's the machine. And here we have some pins, and these are the Raspberry pins. I just put them on this breadboard so it's easier to connect. Then you can see that thing is the sensor. It's a Bosch sensor, and it's quite precise for the price. And then we have a physical button there, yeah? And now I can SSH into the thing. I'm just going to do SSH nerves. And you see it says, okay, Elixir and everything. So now I'm in the matrix, right? So if I do ring logger attach, I can say next to see some messages. And you see most of them right now are kernel messages from the Linux kernel, probably something about random number generation or whatever. But basically here I have this like Elixir environment that's running on this Raspberry Pi. So now if I press this button, yeah, you can see it says button pressed, and it tells me that the machine has gone into this listening mode where it's like measuring the humidity. And just excuse me while I'll artificially increase the humidity in the air. Cool. And you see now it says SMS sent back to idle. And if I check on my phone, I've just got this message that says, the coffee is ready, dude. So this is the demo of the thing. But what I think, like, I think this is like, like very close to the first example that you get when you're playing around with nerves. But something which I really loved is when I discovered this. The Nerves team has been working on this product, which is called Nerves Hub, which allows you to remotely update firmware on all your devices. So basically you can have this fleet of devices out there, and you know the version of the firmware that's running on them. And if you want to, you can just update them all in one mix command, right? So I want to do another demo of Nerves Hub and how cool I think it is. So let me switch back to the thing here and the terminal here. Okay, cool. So here we have our little thing, and I didn't tell you, but there you can see there's this little red LED, and we're going to use that, right? Because now when I press that button, I'm not sure if the device worked. So I want to have a way to know if the device is, measuring temperature, is listening. So what I'm going to do is I'm going to change the server to do that. So in the init function, when it starts, I'm going to open a connection to a pin on the Raspberry Pi. And I'm going to use this library, which is called Circuits GPIO, which was written by the Nerves team, right? And I'm going to open this connection. And if you see clearly, there's like this LED, it has this black cable that goes all the way into GPIO 19, right? And this GPIO 19 is the pin that we're going to use. We're going to say open that. And we're going to say, we're going to open it using an output mode. And then we're going to pass it into our state, right? And the first thing when everything boots, I'm just going to say circuits GPIO write GPIO 0, which means basically when this gen server starts, just turn the LED off, please. Thank you very much. And later, when, for example, the user presses the button, I can just set it to 1. And then when the SMS has been sent successfully, I'm going to set it back to 0 again. And also when the SMS thing fails to send for some reason. Cool. So I think there's some errors. Thank God I've added the LSP, so it tells me what the problem is oh, okay, there's no variable called GPIO, so probably I just need to write state GPIO, right? Here and here. Now if I save, the LSP will tell me everything's cool. Awesome. Now I can compile my app as usual. And it says, you know, the mixed target is a Raspberry Pi 3. And now I can build the firmware. So what this thing will do is, like, with a single mix command, it will create this image of a system with the Linux kernel and your app all together. So, and it will just bundle this up into one, you know, image, which is super easy to use. And I don't know if you try to do cross compilation yourself, but it's nowhere as easy. Because, you know, like the Raspberry has an ARM CPU. It's not like an Intel little thing. So hopefully this should finish soon. And you see, like, it has like this FW little thing. So if I just do LA build dev nerves images, you can see, okay, there's an image here and it's 35 megabytes, which I think is pretty impressive. It's like really tiny, right? But what I said is, like, I want to push this to the device, right? So what I'm going to do is I'm going to use this command that has been given to me by the Nerves Hub package. And I'm going to say, okay, I want you to publish this firmware. I want to use this private key to sign the image, and I want to deploy it using this deploy mechanism, right? So I'm going to do that, and it's going to ask me something. It's going to ask me, oh, well, first of all, are you sure you want to publish this firmware? And then it's going to ask me for my local, for my password for using my private key to sign the image, which I'm going to provide. And then it's going to ask me the password to use Nerves Hubs, which I'm going to provide. And now it's uploading the thing on the cloud. Let me just, I already enabled the ring logger, so it's really cool. So let's just wait a few seconds. I'll drink some water. You can see it's almost done. Perfect. And I want to switch to, this is the device itself, right? You see the device now has noticed there was a newer version of the firmware, has pulled it, and now it's like flashing it on itself. And you see it kicked me out from the SSH connection. And the way it works is, I think by default, there is a WebSocket connection that's basically connected to Nerves Hub. You can see it at some point realized there was a new version of the firmware that was stored on S3, and it started a stream, and then it started doing like the firmware upload. I think it says partition A because it creates like two partitions, whatever. If I now SSH into the thing again, you see the thing is back up, and now it should be working. So let's try it out. Ring logger attach, we're attached. if I press the button, you see the light is on. So now like the robot now tells me when it's actively listening to, well, it's just, humidity and temperature information, but still, it could be much worse than that. So let me again increase the level of humidity in the air artificially. You see, now it's sent me another text to tell me that the coffee is ready, and I got another text message, and the LED now is off. I think this is like incredibly cool, but what's something even cooler probably is that on the web interface of Nerves Hub, you can see everything. So for example, you can see I have this device. It did this last handshake 4 seconds ago, and I can see more about it. So I can see the whole history of deployment to this device. And I've done quite a lot of testing. But what is even better, I can open a remote IEX console to it. So right now I'm in the box, and I can do, for example, Moke sensor humidity. It says 52%, right? And you have basically a complete control like over the whole device. And right now I have only one, but it's just a detail. I could have 1,000 out there of coffee measuring robots. So I don't think I will have time for the other demo, but I'm just going to quickly talk about it. So the other demo is a small robot that checks for bus stop times and tells me when I have to leave the house in order to get that bus. And you can see more on the GitHub repo. You can find all the slides and all the links to the articles I was talking about on this repo. And you can talk to me on Twitter. And that's the end of my presentation.
Thank you, Drew. Yeah, great. So we're all doing this virtual round of applause thing already. Let me just do my bit. And we can take a look at questions. I need a moment because I actually have to reload the page to make sure I can see the questions, because apparently it doesn't update properly. And I'm just doing that, clicking right now. Okay, so Daniela, I hope you can unmute yourself and go ahead and ask your question. Okay, it sounds like maybe that's not the case, so I'll go ahead and ask that. So Drew, is there any specific reason why you didn't choose a Gen state machine for the sort of Gen server you wrote?
I should have. I was just lazy, but I think it's every time you don't want to use a Gen like a Gen state or a Gen FSM, 5 minutes later you realize you should have when you're modeling a state machine. So you definitely should use those libraries every time. I was just lazy and didn't want to do it. Yeah, that's the only good answer.
Okay. So since we have plenty of time, I'm just going to try that reload again in case there are in fact even more questions. And in the meantime, please don't hesitate to unmute yourselves and ask a question sort of more ad hoc. There is another question. It's a good thing I'm reloading these. Nicholas, I think you were able to unmute your microphone earlier today. Maybe you can do that again and ask your question. Okay, sounds like no. Right. So I'm asking that again. Drew, can you host a Nerve Hub server yourself? In case Nerves gets brought down by the devil.
Yeah, I don't know. That's a really good question. I think I've seen like previous iterations of this like Nerves Hub sort of idea, and before you just did it like yourself, right? And I think the way it works, it opens this HTTP server on the little thing, and it listens for events. So I think like in theory, you could rebuild the whole stack yourself. I haven't really explored how. I have a lot of confidence, like in the Nerves team, that they're going to do a great job with Nerves Hub. So I haven't really looked into that. Like, I'm the sort of guy that sticks like two things together, and if they stick together, it's good enough for me. But definitely, like if you're interested into doing something like in-house, all the tools should be out there. Maybe they're a bit hidden, but they're definitely out there, and you can rebuild something like this like by yourself. I think a couple of years ago I already heard someone talking about this idea of having multiple partitions. So when you're doing the flashing of the new firmware, there's always like a backup partition in case the new firmware was failing for some reason and you failed to boot, and it would like revert to the previous partition. I definitely know like all these bits are out there. I don't have the details on how you would build that part yourself. I think that's the part of the talk, where I said limitations apply. I think, like there are some things which take too much time to figure out yourself, and you have to trust someone. But I definitely trust more the Nerves core team than Amazon.